Page 103, number 56. Question 56. Two crates with masses 15 kilograms and 35 kilograms are stacked on the back of a truck with the lighter crate on top of the heavier. The frictional forces are strong enough that the crates do not slide off the truck. The truck is accelerating at 1.7 meters per second squared. Draw free body diagrams for both crates and determine the values of all forces. Indicate the direction of the truck's motion in your diagrams. In the question, we have been given mass 1 is equal to 15 kg, mass 2 35 kg, and the overall acceleration of the truck and the crates is 1.7 meters per second squared. In the diagram, mass 1 is on top of mass 2, and the direction of the truck's acceleration is to the right. The free body diagram of mass 1. There are three forces: the normal force which acts up, the force of static friction, and the force of gravity down. To explain the force of static friction, if the acceleration of the truck is to the right, then the force of static friction must also act right. This ensures that the crate and truck will accelerate together and the crate will not fall off. The free body diagram of mass 2. There are two forces, force of friction of 1 and force of the normal of 1, which are caused due to Newton's third law. With every action force, there is a reaction force. The reaction force is always the same magnitude but opposite direction to the action force. Because the truck is accelerating right and the static friction on M1 is acting right, then the reaction force of the static friction of M1 acting on M2 moves to the left. Same with the normal force acting on 1. On M1, the normal force acts up, opposing gravity, but the reaction force is shown as a force of the normal acting down on M2. Then there is the force of gravity down and the normal force up, as well as the force of static friction on 2. The required. There are 6 forces required to solve this problem. The force of gravity, the force of normal, and the force of static friction both all on 1, and the force of gravity, normal, and static friction all on 2. Then we look at the analysis of the first mass. We look at their x component. F net is equal to ma. But F net is also equal to a force of static friction of 1 because force of static friction is the only force acting in the horizontal direction. Therefore, force of static friction of 1 is equal to 15 times the acceleration of 1.7, and force of static friction is equal to 25 newtons. Then the y component. F net is equal to 0 because there is no acceleration in the vertical plane. Taking up as positive, F net is equal to the F of the normal force of 1 subtract the force of gravity of 1. So 0 is equal to F of the normal subtract mg1. Therefore, F of the normal is equal to 15 times 9.81, giving us a force of normal of 147 newtons. Then we analyze mass 2. To calculate the x component, we take right as positive, and the net force will be the force of friction on mass 2 subtract the force of friction on mass 1. Therefore, F net is equal to F static friction of 2 subtract force of static friction on 1. Mass 2a is equal to the force of static friction on 2 subtract 25, giving us a force of static friction on 2 as 85 newtons. Then we calculate the y component. If we take up as positive and the net force as 0, as there is no acceleration in the vertical plane, then the net force is equal to the normal force of 2, subtract both the normal force of 1 and the force of gravity on 2. F net is equal to Fn2, subtract Fn1, subtract Fg2. And 0 is equal to the force of the normal on 1, subtract the force of gravity on 2, subtract 147, which is the number that we previously derived, giving us a normal force of 490 newtons in total. In conclusion, we have found 6 forces. Force of gravity on 1 and force of the normal on 1 is both 1.5 times 10 to the 2 newtons. Force of friction on 1 is 25 newtons. Force of gravity on 2 is equal to 3.4 times 10 square newtons. Force of the normal on 2 is 4.9 times 10 to the squared newtons. And force of static friction on 2 is 85 newtons. Thank you for watching!